Let us look at proposition number 16 of book 4 of Euclid's Elements. This is the last proposition of book 4. Now the proposition talks of constructing an pentadecagon, that is a polygon with 15 sides in a given circle. So basically we have to inscribe it inside a given circle. It may look, based on our previous 2-3 propositions, it might look that it's going to be very, very complicated. It is actually not. What we have to do is we have to inscribe a equilateral triangle inside this circle. And then we have to inscribe a pentagon inside this circle. For equilateral triangle, we have already created this. So we have to inscribe it. For pentagon, we have created a triangle an isosceles triangle whose equal angles are double the third angle. So we just inscribe equilateral triangle and then we inscribe the isosceles triangle and then we'll see what happens. Let's take a point A anywhere on the circle. Since we have already done this, I'll just keep carrying out the steps. So we are copying the angles of the equilateral triangle and see intersection of these rays with the circle. Okay, and then finally we join AB, BC and AC. So we have constructed or inscribed a equilateral triangle. So now let's hide off all these things that we don't need. Okay, now let's begin with the pentagon, where we have to inscribe this isosceles triangle inside the circle first. So again we copy angles. Again we know how to copy. Okay, so now we bisect this angle and angle GAE and AGE, right? So we have to bisect it. So let's bisect it and take the intersection with the circle of these rays, of these lines. And now let's join these points. So now we have got the pentagon. So we have the equilateral triangle and we have the pentagon. Now what's the fun of this? We know a pentagon will cut this circle into 5 equal parts, right? And it will, the triangle, equilateral triangle will cut it into 3 equal parts, 3 equal circular segments. That means A to C is the segment which is cut by the equilateral triangle and AG is the circular segment cut by the pentagon. Now if we take AGC, we have one circular segment cut by the equilateral triangle and we have an equal segment and a part of the second segment. So from A to C, we have how many segments cut by the equilateral triangle? 1/3 of the complete circle. Between A to G, the circular segment is 1/5 of the complete circle. We know in a pentadecagon is 15 sides. So that means A to G will have how many equal segments of the 15 gone? That is pentadecagon. This cuts it into 5 equal parts. There are supposed to be 15 equal parts of the circle. So here you will have 15 divided by 5. That is 3 equal segments between A and G. And between G and C, how many will be there? Now to figure out that, let's look at the triangle. One side of the triangle. AC, circular segment, will have how many parts? 15 divided by 3. That is 5 equal segments. So A to G, 3 segments. A to C, 5 segments. That means between G to C, how many segments? 5 minus 3, 2. So between G and C, we will have 2 segments. So now, which means we can bisect GC and get 2 equal segments of the pentadecagon. So let's do that. So let's join G and C. Let's take a perpendicular bisector of that. Let's take the intersection of this bisector with the circle, and let's draw the line segment from G to that point and join these two. So that means from G to this point, we have one part of the 15 pentadecagon, and we have the second one here, C to this point. Now finally what we do, we copy this, or we cut this entire circle repeatedly with a segment equal to this segment. Cut basically means fit this segment repeatedly throughout the circle. So let's see. Let's first get rid of this line. And now we don't even require, we know how to fit. So I'll just keep doing it. So we have got the pentadecagon, or rather we have inscribed a 15-sided equiangular and equilateral polygon inside a given circle. While constructing itself, I gave you the proof also. One side of the pentagon will cut it into 3 equal parts, because the pentagon cuts the circle into 5 equal parts. So 15 divided by 5 is 3. Similarly, this will cut it into 5 equal parts. Why? And this will 15 divided by 3 will give us 5. So 5 minus 3, this will have 2. So we bisect it to get 1. And that we keep copying or fitting it into the circle in a circular manner. So that was proposition number 16 of book 4 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share it. That's it for now. Bye.